Hello, welcome to Plutus IS. So today we will solve one more question of linear algebra. Previous year question. This question has been asked in 2021. We have to show that A square equal to A inverse without finding the A inverse. Matrix has been given. That means there is a matrix of 3 into 3, and then we have to show that the A square equal to A inverse, and without finding the A inverse means it cannot find the A inverse by as usual method. We know that the how to find the A inverse. That means inverse of a matrix is by using the the determinant and adjoint and so on, even by using the echelon form, reduced echelon form and so on. So without finding the A inverse, we have to show that A square equal to A inverse. Actually, this question is asked the application of Cayley-Hamilton theorem. So we will see that through Cayley-Hamilton theorem we can prove that A square equal to A inverse. So first we will see what is the Cayley-Hamilton theorem. We know that the every square matrix, every square matrix, every square matrix satisfy own characteristic equation, own characteristic equation. We know that that is the Cayley-Hamilton theorem. Cayley-Hamilton theorem said that every square matrix satisfy own characteristic equation. That means, and what is the characteristic equation? We know that the A minus lambda I determinant equal to 0. That is the characteristic equation. Characteristic equation. So we will use the Cayley-Hamilton theorem to show the A square equal to A inverse in particular question. So how to solve this question? So first we will find the characteristic equation. So the characteristic equation of the given equation, the characteristic equation of the given matrix A is A minus lambda I equal to 0. We can use direct formula, that is the, you can also calculate by the, in terms of 3-degree matrices, lambda cube minus trace of matrix A, and then plus then lambda square, and then plus cofactors A11 plus A22 plus A33 lambda minus determinant of A equal to 0. So we will find therefore lambda cube. And what is the trace of a matrix? Trace of matrix means simply sum of diagonal elements. So sum of diagonal elements, that means 1 plus minus 1 and plus 0 equal to delta is 0. So 0 lambda square plus what is the cofactor A11, calculate, then we will get the 0, plus A22, then we will get the minus 1, get the minus 1, and A33 will get the minus 1 and plus 2, that means we will get the 1 lambda minus, and what will be the determinant? If you want to calculate the determinant, we will see here that take the expansion through this one, so we will get the here plus minus plus. So corresponding to this, we will get the determinant. If you calculate the determinant, what will be the value I directly put here? So we will get the 0 and minus minus plus 1. That means plus 1 equal to 0, or lambda cube, that is the 0, also 0, and minus 1 equal to 0 is the characteristic equation, is the characteristic equation of matrix A. So now by Cayley-Hamilton theorem we know that every square matrix satisfy its own characteristic equation. So obviously this matrix A will satisfy the characteristic equation of the matrix A. So now we'll write, so by Cayley-Hamilton theorem, we know that every square matrix matrix satisfy its own characteristic equation. Therefore, we have, so A will satisfy the characteristic equation. Therefore, we can put the here lambda q, that means AQ equal to A. And we have AQ minus I equal to 0. So here 1, that means here the put the identity matrix, so let AQ minus I equal to 0. So or you can write the A cube equal to I, or imply that now A is a non-singular matrix, a determinant is non-zero, and obviously so A inverse exists, so we can multiply by the both side A inverse, so we'll get the A inverse A cube equal to A inverse into I. That imply that A square equal to A inverse. So we have to show that A square equal to A inverse without finding the A inverse. So we can see here that we have proved that A square equal to A inverse in this case without using the A inverse. That means without finding the A inverse. Obviously we have used the A inverse, but yes, without finding the value of A inverse. So by using the Cayley-Hamilton theorem, we can solve this type of problem. So it's a very important problem regularly asked by the Cayley-Hamilton theorem in the UPSC. So we'll see the more questions in the upcoming videos. Thank you.